In this problem, you're asked to simplify an expression that involves negative exponents. And always, my advice to students, if you're trying to simplify an expression that has negative exponents, is to rewrite the expression so that the exponents are positive. So in this case, I'm going to show my work down here. So I have x squared, I'll leave that alone. Y to the negative 5. So I'm going to write that as 1 over y to the 5th. So write it as a positive exponent written in the denominator of the smaller fraction. Same thing with the x to the negative 3rd power. So I'm going to write that as 1 over x to the positive 3rd power. Plus, there we have y to the negative 2. So I'll write that as 1 over y squared. So now what we're looking at is a complex fraction. That's what you call it whenever you have fractions within a larger fraction, like we do here. To simplify a complex fraction, it's best to multiply numerator and denominator by the least common denominator of these little inner fractions, the x cubed, the y squared, the y to the 5th. So to find a least common denominator with terms like this, we want to include, well, first of all, certainly a power of x and a power of y. And we want to include the greatest power of x that we see. So we just see one power of x, it's x cubed. So we'll have x cubed in the LCD. And then of those powers of y, the greater power is y to the 5th. And so this is going to be our least common denominator. We can simplify the complex fraction by multiplying the entire numerator and the entire denominator by that LCD, x cubed, y to the 5th. So I'm going to multiply the numerator by x cubed, y to the 5th. So when you do that, make sure that you distribute to both parts. You have to multiply everything by x cubed, y to the 5th, whether or not you need it, to clear a denominator. You have to multiply all the way across. So the x squared that we had, we need to multiply that by x cubed, y to the 5th, minus 1 over y to the 5th, times x cubed, y to the 5th, all over 1 over x cubed, and you get the idea. Over y squared times x cubed, y to the 5th. And now's the fun part. We get to cross out some common terms, like y to the 5th would cancel here, x cubed would cancel here, and here we can cancel y squared. Since we have y to the 5th up here, we really just need to take 2 away from that exponent, so now it's y cubed. Now, also note that with expressions like this, so x squared times x cubed, you should add the exponents. Let me write a little scratch work off to the side up here. So x squared times x cubed is equal to x to the 2 plus 3. So, x to the 5th. So down here, x squared times x cubed, so that's x to the 5th times y to the 5th, minus x cubed, since the y to the 5th is canceled. Down here you just have 1 times y to the 5th, so just y to the 5th here, minus 1 times x cubed, y cubed. Okay, and then there's one last thing we can do here. We could factor out some common factors across that numerator. You've got a common factor of x cubed. So to figure out the remaining power of x, you just subtract 3. If I had x to the 5th right here, and I factored out x cubed, then now I have x squared, y to the 5th, minus 1 as a placeholder where we used to have that x cubed. And then in the denominator, you've got a common factor of y cubed. So since I had y to the 5th, I now have y squared in that position, minus x cubed, and the y cubed was already factored out. So this would be our simplified form.